Hello everyone, and welcome to the awesome Matchmove artist course. Thank you for being here with us. My name is Igor Eyth. I live in Los Angeles and work as an on-set supervisor. And I also take on projects as a VFX producer, generalist, matchmover, and compositor. I've been working in tracking and matchmoving for a long time and consider myself as an expert in this field. That's one of the reasons why we created this course. What is tracking and why is it used? Tracking is the process of determining the position of a point or a group of points across a sequence of frames from frame to frame. Tracking is used for image stabilization, matchmoving, calculating 2D or 3D object camera motion within a shot. Before digital image processing, tracking was practically impossible. There were attempts to do it manually, but the human eye is incredibly sensitive to even the smallest inaccuracies in motion, often requiring sub-pixel precision to fool it. What is sub-pixel motion? If we move an object exactly 1 pixel, it's easy, it simply shifts. But if the movement is less than 1 pixel, gradients appear, and estimating such tiny shifts by eye becomes nearly impossible. Any uneven manual tracking becomes instantly noticeable. On top of that, objects in real life never move perfectly aligned to a pixel grid. The history of tracking began with single-point tracking, used to stabilize shots or add motion during compositing. One of the first VFX uses of tracking was around 1985 in a commercial for National Geographic, where a gold coin moved along an arc like a rising sun. The coin had to be stabilized and match-moved with a sunrise plate. At the time, ILM used a 2D tracking system called MM2, which was used in Hook and Death Becomes Her. It was not automatic, artists had to manually adjust each frame. Later, ILM evolved this into one of the first 3D tracking systems, which was used on Jurassic Park. With the emergence of 3D tracking and software like 3DEqualizer, Buju, PF-Track, tracking evolved rapidly. Later came optical flow technologies from the Foundry and Pixel Farm, photogrammetry, laser scanning. Types of tracking: 2D tracking, tracking a single point across frames. Planar tracking, tracking a moving plane. Optical flow tracking, tracking groups of pixels based on motion flow. 3D tracking, solving camera or object motion in 3D space using 2D track points, camera parameters, lens distortion info. How does 3D tracking work? The software takes in motion of 2D points, sensor parameters, lens info, lens distortion, optional known camera movement, estimated 3D point locations. Then the solver analyzes all that and reconstructs the camera motion in 3D. The more information you give, the easier and more accurate the result. Less info, and you'll need tricks and guessing. What is parallax? Parallax is the apparent shift in position of an object relative to the background as the observer moves. It's a key factor in accurate 3D tracking. If points shift relative to each other, the solver can calculate their depth and the camera path. If there's no parallax and no other data, 3D tracking is nearly impossible without cheats or assumptions. Camera motion types and their impact. The more you know about the camera's motion, the easier it is to track. If tracking points are sparse, you can help the software by specifying the camera motion type, supported in tools like 3DEqualizer, Nuke, PF-Track, etc. Common camera motion types: free camera movement. Pan, stationary camera rotating on tripod. Nodal, tripod-mounted pivot-only motion. Linear and dolly, physical movement forward or backward. For example, in a pan there's no parallax, so the solver can't infer depth. But if you tell the software it's a pan and provide height and tilt, it can solve correctly. If you don't, the solver will go crazy. Linear movement is very informative and clear for tracking, but it's important to understand the difference between dolly and zoom. Zoom changes lens focal length, altering field of view and distortion. Dolly, physical camera movement, no change in lens characteristics. In this course, we're referring to camera movement, not zoom. 3DEqualizer can even distinguish between planar and arc motions. We'll cover that later. If there's not enough data, you can manually assign a motion type to a section or the entire shot. Camera and lens, why parameters matter. To get accurate tracking, it's important to define sensor size, lens type, focal length. If shot with modern cameras and lenses, these parameters are often stored in metadata, making the job easier for the on-set supervisor. If not, it's up to the supervisor to gather and provide them. Sensor size and focal length are tied together. If you specify the wrong sensor size but the right focal length, the solve will be inaccurate. Focal length is the distance from the lens's optical center to the camera's sensor plane. It strongly influences how an image is perceived. Sensor size is a critical parameter. Together with focal length, it defines the field of view. This is the portion of the scene that fits into frame at a given lens and sensor setup. Focus distance, the distance from the subject to the camera sensor. It affects minor changes in focal length and lens distortion. This is known as lens breathing. Lens types: prime lenses, fixed focal length, typically with less distortion. Zoom lenses, variable focal length, often with stronger distortion. Spherical and anamorphic lenses. Spherical lenses bend light evenly on both axes. Anamorphic lenses use cylindrical elements. They scale the image differently in vertical and horizontal directions. Lens distortion is a critical parameter in 3D tracking. In 2D tracking, it's minimal, but in 3D, it's crucial. What can be done? A distortion grid is shot for each lens and camera combination. Tracking software can remove distortion and reapply it later during compositing. In some cases, distortion can be auto-calculated using track points, but this only works for simple lenses and good quality shots. For complex lenses, you'll need a properly shot grid test. How a distortion grid works. A regular checkerboard grid is filmed, it passes through a distorting lens, the software analyzes the distortion of the grid and generates a distortion model. Tracking tech is constantly evolving. If you understand the process well, you can track virtually anything. But remember, the better organized your shoot is, the easier the tracking will be in post. The on-set supervisor must take precise measurements, capture reference photos, place tracking markers, record camera motion, document sensor and lens parameters. The more shots you track, the better you'll understand what needs to be prepped on set so you don't end up fixing it all later in post. So, welcome. Let's dive in and start learning. All of this is foundational knowledge. I understand many of you already work in CG and know a lot, but reviewing the fundamentals is essential. Without this clarity, it'll be hard to move forward. Some of this may be familiar, some may sound new or abstract. Don't worry. Ask questions on the live streams, ask for clarification. We'll revisit all of this many times. Welcome. Let's go.